Okay, so this question here, this is about reactivity at the beginning, and it wants us to use the information in the table to produce a reactivity series. So the best way of doing that is we've obviously got to take the information in the table into account, and then, as you can see here, it wants us to go from least reactive to the most reactive. So looking at the information, X only has a few bubbles, which from those descriptions is going to be the least reactive. The most reactive we've got here is probably Z. Its bubbles are formed very quickly, so we're going to have Z at this end here. And then we need to separate out W and Y. So W bubbles are formed quickly with some metal remaining after 3 minutes, and the other one is bubbles formed quickly, but after 3 minutes the metal's reacted. So that means that Y is more reactive than W, so we have got the correct order. Okay, next one. I've got an equation here showing you how a metal reacts with an acid, and it says when the metal Y reacts with dilute acid, bubbles are seen at first because we're getting this hydrogen gas produced, so there's the bubbles, and then the reaction stops. Most of the solid metal remains. Explain why the metal stops. So the reaction stops. The reason the reaction is going to stop, even though there is some metal left, is because the metal sulfate that is formed is insoluble. And what that's going to do, it's going to form a barrier. So imagine you've got your piece of metal there, and as the sulfate forms, it's insoluble, it forms a little barrier, and that means that the metal underneath or below that surface is unable to react. So we need to finish that off with a second mark. So that barrier prevents the metal from reacting fully. Okay, so 2 marks, 2 answers. Okay, definition of a weak acid. So weak acids, they are acids which only partially dissociate. So they partially dissociate, and that's going to lead to fewer hydrogen ions are produced. So they partially dissociate and fewer hydrogen ions are produced. 1 mark for each of those 2 parts. Okay, we've got some calculations to finish. So here's the formula for aluminium sulfate. Calculate the total number of atoms that combine to form 5.3 grams of aluminium sulfate. Well, the first thing we need to do is let's change that mass into moles. So I'm going to use the triangle here where I'm going to try and find the moles, and moles is mass divided by the MR. So let's write that down. We're going to do, we want to know the moles, so the moles is going to be the mass divided by the MR. So the mass in the question is 5.13. We need to work out the MR, and we can do that because it's given us the formula and it's given us a relative atomic mass. So I'm just going to come down here out the way, and let's work out Al2 SO4 3. Let's work out the relative formula mass for this. So in this formula, there are 2 aluminiums, there are 3 sulfurs, and there are 12 lots of oxygen. So aluminium's mass is 27, sulfur's mass is 32, and oxygen's mass is 16. Okay, bit of calculator work. So 2 times 27 is 54, that's 96, 12 times 16 is 192. And then we're going to get the total by adding these together, Now let's do that. So I've got 342. So my MR up here is 342. So now what I'm going to do is 5.13 divided by 342 is 0.015, and that is moles of the substance. Okay, so we've worked out the moles. Now what we're going to do is we're going to use this to work out the number of particles. And the particles we're trying to find are the particles of the atoms. Okay, so particles is moles times AC. So I have worked out I've got 0.015 moles, and times that by Avogadro's constant. So let's just do that step in my calculator. And that's equaling 9.03 times 10 to the power of 21. Now remember that is aluminium sulfate. That's how many aluminium sulfate particles I've got. But the question wants me to work out how many actual atoms there are. So if I take this here, I've got 2 aluminiums, I've got 3 sulfurs, and I've got 12 oxygen atoms in here. So if you add those up, I've actually got 17 atoms. What I need to do is take that number we've just worked out and times that number by 17, and that's going to tell me exactly how many atoms I have got. So that's given me 1.54 times by 10 to the power of 23 atoms. Okay, so my final answer is that one, because we have to times by 17 because there's 17 atoms in 1 mole, and therefore we need to know how many atoms there would be in this 0.015 moles. 4 marks in there. The marks would come from working out the moles here, calculating that MR, then you've got working out that bit and then times it by 17 to give you a final answer. So in this question, we're going to be using our favourite triangle, the Mr. Moses underneath the mass. And what we're going to do, as we always do in a calculation, is we're going to take these amounts and we're going to convert them to moles, okay? So if you want to do moles of iron, according to the triangle, moles is mass divided by the MR. The mass from the question is 4.48, and we're going to divide that by 56. So 4.48 divided by 56 is 0.08 moles. Do the same for lead. So moles of Pb is going to be the mass divided by the MR. So the mass is 24.84 and the MR is 207. So 24.84 divided by 207 is 0.12 moles. I want to get a ratio here. So what I'm going to do next is I'm going to divide those two answers by the smallest. So put a little note in here, divide by the smallest. So if you divide 0.08 by itself, because that's the smallest number, I'm going to get 1. And if I do 0.12 divided by 0.08, I'm getting 1.5. Can't have 1.5 of an atom for the lead, so let's times that by 2. So therefore I get 2 lots of the iron and I get 3 lots of the lead. So these two numbers here are the ratio in which these two exist, and I'm going to use that to then go back to the question and check which equation has the same ratio. So if I look here, iron to lead is a 1-to-1 ratio, so it's not that one. There's 2 lots of iron and there's 3 lots of lead, so that is a 2-to-3 ratio, which is the same ratio we've got here. So therefore, and always tell them this, therefore equation 2 is correct. Okay, So marks wise, you're going to get a mark for stating that. So make sure you tell them which equation is going to be correct. And in here, you're going to get a mark for working out the correct moles in each of those two examples.